So now our chemical reaction has kind of completed. What do we see now?
Yuck.
Raise your hand if you have an observation. Yeah.
Yuck.
Yuck. Okay. Yeah?
Looks like dirt.
Looks kind of like dirt.
Guck. Something else.
What?
Guck.
Guck. All good words for it. Like?
It looks like sand.
Looks kind of like sand. Does anyone remember the scientific word for this? I said earlier.
Hardness?
No, we did a hardness test. This is a dissolved oxygen test, and this stuff in the bottom, this guck, yuck, whatever you called it, is precipitate or flocculent. And that's the chemical product that settles out at the bottom of this chemical reaction. So now that we have that, we're going to add one more chemical reagent. That's something that's going to react with what's in there and cause it to change into something else. And as I put this in, I want you guys to watch and make some observations and then tell me what you see happening. Oops.
Is that a nails clipper?
They are. So watch this and tell me what you see happening.
Snowing.
Rising.
Whoa!
It's like, it looks like a nebula.
Golly, that's so
For a second. It
Dang,
looked like a
gone.
nebula for a second. And then it's gone.
So that's just pure oxygen, like compacted in a ball.
Not exactly.
Are you gonna shake it?
I am going to mix it.
Shake, shake, shake. No.
So now I'm going to turn it upside down, and now what are some observations? Okay,
There's white stuff.
okay, there's white stuff, that's what I just poured in. Like,
If it falls on it, it looks like it's a lot heavier.
it does look like it's heavier than the other stuff because it moves much faster. Hallie?
It's sort of darker.
What's darker?
The gafish. Yeah.
Okay, the gafish stuff got darker?
The watercolor is liquid color is yellowish.
Yeah, all the liquid turned that yellow color. Before it was just kind of a cloudy off-white-ish. Now it turned really yellow. So I'm going to invert this a few more times to get it really mixed. And then I'll let it settle out. All that gook should start to dissolve. And then we'll take a sample and do our final step for our dissolved oxygen test. Which is going to be another titration. Yeah, Cody?
It looks like beer.
What's that color?
With like the bubbles.
There's a big rusty
It does actually. It looks like
No, 60.
Now the scientific way to say that would be, it's yellow, right? Because if it looks like beer, what's that mean to someone who's never seen beer before? It can also be all kinds of different colors. So if you say it's yellow, that's much more specific.
It looks like yellow brown.
So we're going to finish up our dissolved oxygen test and pour some of this in our sample tube.
Oh, that's
What if we pour that in the liquid? A couple things die.
You know what it also
This is a very small amount, so small amounts probably would make a huge difference, but we still don't want to do that because it could.
Yeah, it's not fish good competition.
See, look at the fizz there.
Yeah, I know.
So this tension.
It's awesome. It's like magic.
Okay, someone want to take one of their water samples and rinse that out and dump it in the waste.
Water sample.
Air sample.
Thanks. Okay, so now our final step is we're going to take this sodium thiosulfate, this is the name of this chemical, and we are going to do another titration, dripping this one drop at a time into here. And while I do that, I want you to count the drops for me and tell me when you see something happen. What do you think is going to happen?
It's gonna change
Dalton?
colors.
It's gonna change colors
Change colors?
into orange.
Blake?
It's also like, it's trans.
It's going to explode.
No. we did that.
It's
Right
gonna
back.
pulse off the picture together.
One more again.
It's gonna start to bubble.
Start to bubble. Let's see what happens. Go to
Turn orange.
a little.
One.
Two.
Wait, can you please move your head down?
Three.
Really clear.
It's
Whoa.
clear.
I was right.
Four.
Oh my gosh, it just instantly changed.
See that?
Oh my god.
Told you to
Should
change
do
So-
colors.
Can we drink it? No.
Dalton was right.
That's what happens when the sodium thiosulfate reacts with all the other reagents and the oxygen. It takes away the color, and you get back to this clear water. So that means that we have 4 parts per million of oxygen compared to water. So I'm gonna take this and dump it in there.
I think it's raining.
Now, what do you think it means to have a reading of 4 for our dissolved oxygen? Do you think that's a lot, a little bit, somewhere in between? What do you think, Kate?
It's somewhere in between.
Somewhere in between. Here's a reading, a graph of our usual dissolved oxygen. And you see there it's around, in the summertime, around 10, 12, and then as the late winter goes on, it gets down to around 4. So our reading is probably pretty accurate. That looks right about what it should be. And that is on the low side. Why would it be low right now? Cody? Yeah, the ice. So the ice is covering up our lake, and there's no mixing going on with the atmosphere, and so the oxygen in there is getting used up. So we don't have as much dissolved oxygen. But when the ice melts, what do you think is going to happen? Brad?
It's gonna go back up.
Yep. There will be more mixing, and oxygen in the air will dissolve into the water, and we'll get more dissolved oxygen. Now, what does that mean for our plants and animals? Here's just a little chart, and top species is bluegill, and you see bluegill need about 5 parts per million of dissolved oxygen. So, do you think that our bluegill, if we have any bluegill in there right now, how do you think they're doing? Yeah, they're getting a little worn out if you have any bluegill. But other animals probably still doing okay. So, not in a lake, but maybe in rivers. So, for a winter reading, that's pretty good. Now tell me about some of your other tests. Who did a nitrate test? Should be everybody. Should be everybody. So what was our nitrate reading? What did you get for nitrates?
Ours didn't show up.
Okay, it didn't show up. Aiden? What? 5. So 5 or less than 5. And anyone know what that means? What are nitrates in our lake? What do they do for us, or are they good or bad? Who thinks nitrates are a good thing to have? Who thinks nitrates are a bad thing to have? Who knows what nitrates are? Who has no idea and is just putting their hands up whenever they feel like it?
Oh. Well, now I really feel it.
So does anyone have a guess where nitrates can come from? There are a couple of different places. Like, not nutrition. Well, actually, in a way, kind of. Allie? Plants and animals do make nitrates. So, nitrates come from broken down ammonia, and ammonia is in anything. It can be broken down food, or once animals eat food, what do they do with it?
Waste it.
Yeah, they turn it into waste, and that waste has ammonia and nitrates in it. It can also come from us and things that we do. Any ideas of what we do that can put nitrates in the water?
Oil.
Oils can.
Trash.
We use manure for something.
Our sewer.
Okay, our sewer
When it
can.
goes like when it rains and it goes through the.
Yeah, so if our sewers aren't well contained, they can leach into the groundwater that can then get into our lakes.
So I guess it's
How about farms? There's lots of farms around here. What
yeah,
do they do?
people dump their pig waste and stuff.
So sure, dumping animal waste and
Fertilizers.
fertilizers. That's one of the big causes of nitrates and phosphates getting into waters is because of fertilizers. So if we don't have a lot of nitrates, that's a good thing, because if we have too much, it can cause the water to almost become toxic and poisonous to the animals. So we don't want that. So low nitrates is good. Good sign. What was one of the other tests that you guys did? Allie? pH. Okay, and what was our pH? Yeah. 6? Anything different than 6? Around 6 is what we got? Alright, so what does 6 mean? Does that mean it's acidic, basic, or neutral? Right around neutral. So neutral is 7. pH scale goes from 1 to 14. Neutral is 7. So 6 is close to neutral, a little bit acidic. And that's pretty good for our animals. Here we have a chart. This chart shows us all the animals that can live in different pH ranges. So if we go from a 6 all the way up, it only looks like one kind of thing can live in there. What is that one kind of thing? Only?
Bacteria.
Bacteria. Looks like only bacteria can live in there. But as the ice melts, our pH will probably go back up, and we'll get all kinds of other things. So we can get plants, and a lot of fish, and all kinds of creatures that live in a range of about 6.5 to 8.5 or 9. So our pH is pretty good, a little bit acidic, but should be okay for most kinds of animals. Plants can live up to most pretty basic conditions. Then there are some creatures, little itty-bitty guys, like called macroinvertebrates. Does anyone know what a macroinvertebrate is?
It's a vertebrate that you can see with your eyes.
Yeah. So, and specifically when we talk about macroinvertebrates in lakes and streams, what do we think of? What? Good guess, but not slugs. Slugs don't have a vertebrae.
Octopus?
Not octopus. Kate?
Snail things.
No,
Okay.
crayfish.
Crayfish are a good example. All these things on the backside here. So, crayfish, all kinds of larvae, so dragonfly larvae, stonefly nymphs, all of those things. They live in our lakes and our streams, and they're what we call a good bioindicator species. Any guesses what that means, Cody?
No.
No? What is a bioindicator? What does it sound like? Bioindicator. What do you think?
Something that has to do with
Not quite the earth. Good guess. What does bio mean? So it kind of indicates the condition of our water, and it's a living thing. So we could do all these tests that we did and lots more to see what the water quality is like. And another thing that we can do, as you may have seen on the other side of your sheets, is look at what kind of animals live here. So if we only find bacteria here and nothing else, do you think that's a good sign or a bad sign? Probably not a good sign. But if we find all kinds of fish, and then we find little tiny creatures that can only live in really good conditioned water, is that a good sign?
Yes.
Yeah. So if we do surveys, we pull out some water and maybe use some nets, see if we can scoop up crayfish and all kinds of other little guys. That means that we have good, healthy water. And though we can't really do that right now because it's winter and our lake is frozen and these guys aren't around, if we do that in the spring, do you think we'd find a lot of them? Yeah, we probably would, because this is a pretty healthy lake. So overall, what our tests tell us is that the lake is in pretty good condition. And as the ice melts, we'll probably get more dissolved oxygen and can have lots of cool things living in it.
Now is the time to keep going.
So, yes, what